So, if we're talking about adding and subtracting rational expressions, it's basically the same idea as adding and subtracting fractions. Okay, so let's look at an example of how we did that, and then we'll kind of extend that idea so that it'll work with our rational expressions. Let's say that we have 7 over 12 plus 13 over 42. If I want to add two fractions together, what do I have to do that? That's incorrect. So we multiply straight across, but we do not add or subtract straight across. We need to have a common denominator. Okay? So addition and subtraction are the piece where we require a common denominator. How do we find a common denominator? And hold on, let me rephrase that for a second. So we need a common denominator, correct. Now, when we add and subtract fractions, any common denominator is usually going to be fine. We might have to do a little bit reducing at the end, but like reducing fractions is not that big of a deal. When we start talking about rational expressions, reducing could become a big deal, right? If the polynomial is something that's not easily factorable, if you get too big of a polynomial, reducing can be really difficult because factoring isn't always easy for polynomials. Everybody agree with that? So any common denominator is not really the standard we're going to be looking for. We specifically want the least common denominator. Okay, with that? And that's going to become critically important when we move forward talking about rational expressions, is we got to make sure we're finding the least common denominator. So, how do we find a least common denominator for a fraction like 7 over 12 plus 13 over 42? You're going to want to look at the prime factorization. So 12 is 2 times 2 times 3. Everybody's okay with that? 42 is 2 times 3 times 7. Okay with that? My least common denominator has to contain each unique prime. How many different prime numbers do we see between those two denominators? 3. A 2, a 3, and a 7. Everybody agree that those are the unique primes? Now, the number of each of those primes that we need is going to be the maximum number of times that prime occurs in each denominator. So let's look at the 2's first. What's the most number of times the 2 occurs in each denominator, though? Not total. Twice, right? It occurs 2 times there, but only 1 time there. So the most number of times the 2 occurs is twice. You guys okay with that? So I'm going to put an exponent of 2 on it because the most number of times the 2 occurs is twice. Now let's look at the 3. Happens 1 time there, 1 time there. So that's 3 to the first, The 7 happens one time there, so the most number of times that occurs is once. So my least common denominator should have 2 2s, 1 3, and 1 7. Is everybody okay with what we did there? Okay. So if I look at this first denominator, if I look at the 12, what is that missing? I have 2 2s. I don't have the 7, though. So I'm going to multiply the top and bottom of that by 7. Now let's look at the other fraction. Here I have, so I know I'm going to have to multiply. I have 1 3, and I have 1 7. Is everybody okay with that? So I just needed to multiply that one by 2 over 2. Now that they have a common denominator, we can just add the numerators and the denominator stays the same. Are we done? We still need to check to see if we can reduce. So let's do that. 75 is 3, 5. 84 we know is 2 times 2, 7. So there should be a 3 we can reduce out of that. Leaving me with 5 times 5 on top and 2 times 2 times 7 on bottom. This process is considerably more difficult than multiplying or dividing, right? The good news is this doesn't get considerably more difficult when we extend it to rational expressions. So that's good. Okay. We ready to look at some rational expressions, or do we want to do another fractions example? Yep. Let's do actually let's do that. Okay. We want to start by doing our prime factorization, but we really only care about the denominators, right? So 30 is 2 times 3 times 5. 63 is 3 times 3 times 7. What's my least common denominator going to be? Well, I know it's got to have a 2, a 3, a 5, and a 7 in it. Everybody agree with that? How many 2s should I have? Just 1. How many 3s should I have? 2, because the most number of times 3 occurs is twice inside of any of the fractions. And then how many 5s? 1. And how many 7s? 1. Okay. So that exponent is not the total number of times that number occurs, but it's the most number of times that occurs in one of the denominators. So this first fraction, what am I missing from my denominator? I have 1, 2, but I only have one of the 2, 3, so I need a 3. I have 1, 5, but I don't have a 7 either. Okay there? If I look at my other denominator, I don't have a 2. I do have both 3's. I don't have the 5, but I do have my 7. Everybody's okay there? So now I'm going to go ahead and multiply. When I multiply straight across, oh, too early. That's 357. Bang. Nobody thinks that's funny? Okay. And then 630. I think that's right. Let's double check. It's early. Oh, good.
You just multiply everything for us?
That's how we multiply fractions. It's just straight across. And then, oh, that I don't need a calculator for. 19 times 2 times 5 is 190. And then 63 times 2 times 5 is 630. So 357 minus 190 is 167, excuse me. And then the denominator stays the same. I should check to see if this reduces, but I know that my denominator only contains 2, 3, 5, and 7, so those are the only 3 numbers I need to check to see if they can reduce 167. I know 2 isn't going to work because it's not even, because 167 isn't even. I know 5 isn't going to work because 167 doesn't end in a 5 or a 0. I know 3 isn't going to work because the digits 1 plus 6 plus 7 don't add to give us a multiple of 3. So all I really need to check is that to see if 7 divides it. It doesn't, so this will not reduce. I don't really care what the prime factorization of 167 is because I know the prime factorization of 630. It's right there, so I just check to see if there's any factors in common between 630 and 167. And since there weren't, I didn't bother to actually factor the numerator. Is that okay? Okay. So let's look at an example here. Let's say we have 3 over x plus 3 plus 7 over x minus 2. Our first step, just like for the fractions, would be to factor the denominators. Can I do anything to the x plus 3? No, right? That's already done. That's factored. There's nothing more to do there. So I'll put a parenthesis around it to show that it's like already my factor. How about the x minus 2? Can I do anything with that? No. Again, can't factor that anymore. So I'll just put a parenthesis around it to kind of indicate that it's already done. So let's make our least common denominator. In this case, how many prime factors do I have? I have 2. I have the x plus 3 and the x minus 2. Those are my prime factors. Is everybody okay with that? How many times does the x plus 3 happen? Just once. And the x minus 2, just once. So far, so good. So that's going to be my least common denominator. So if I look at the first fraction, I have the x plus 3, but I don't have the x minus 2. So I need to multiply that to the first fraction. If I look at the second fraction, I have the x minus 2, but I don't have the x plus 3. So far, so good. Okay. Now we'll multiply. So the numerators, all I have to do is distribute. And the denominator, to multiply that out, I'd have to FOIL it, right? I'm not going to FOIL that out right now because I might still need to reduce later, and it's much easier to reduce when the denominator is already in a factored form. So I'm just going to do that. Is everybody okay with what I did there? Now we'll just combine our like terms. So 3x and 7x is x. Negative 6 and positive 21 is positive 15. So there the addition is done. So I just need now to check to see if I can reduce. The denominator is already factored, which is nice. So I'll just need to factor the numerator and then check to see if there's anything I can reduce. The numerator, I noticed, is a greatest common factor of 5. But even if I pull that greatest common factor of 5 out, there's nothing in common to do any reducing with. So I would be finished at this step. Let's do another. Okay? Okay. Again, if I'm going too fast through something or you're not sure exactly what I'm doing, stop me. I'll re-explain. I'll go slow down. It's not a big deal. I get that this is not trivial. Okay. What is our first step? We want to factor the denominators. Okay. So x squared plus 7x plus 10. How does that one factor? You guys should be spitting these out pretty quick by now. I'll wait and let you guys think about it for a minute. 5 and 2, good. So x plus 5 and x plus 2. How about x squared plus 9x plus 20? 4 and 5, good. So our least common denominator then is going to contain what factors? Well, I see x plus 5. I see x plus 2, and I see x plus 4. Everybody agree with that? How many times does x plus 5 occur or the most times x plus 5 occurs in one fraction? once. The x plus 2 and the x plus 4. Okay? So that's my least common denominator. If I look at the first fraction, I have the x plus 5, I have the x plus 2, I don't have the x plus 4. If I look at the second fraction, I have the x plus 4, I have the x plus 5, but I don't have the x plus 2. Everybody so far so good? Okay. So I'm going to FOIL the numerators out. So I did the foiling out in my head. If you're wondering where the foiling was, I just did it in my head. If you need to write it out, that's perfectly fine, no big deal. I'm just letting you know that I skipped that step. It seems like from looking at your guys' work, that's something you feel pretty comfortable with doing, so I just went ahead and skipped that. But if you try to FOIL it out on your own, you'll get the same result, I promise. Okay. So now is the tricky part for subtraction, and this is the piece that students inherently forget about and make a mistake with. The negative sign on this subtraction needs to distribute through that entire numerator. So I'm going to rewrite that as a plus and distribute the negative through. So when I do that, I have x squared plus negative x squared, that's 0. 3x plus negative 4x, that's negative x. And then negative 4 plus a negative 4 is negative 8. And the denominator is going to stay the same. Last step would be to check to see if I can reduce. I notice there's a greatest common factor of negative 1 in the numerator that I can factor out. But that doesn't really allow me to reduce anything, so this is just going to be my final answer. Evan? Certainly. No problem. Okay, should we do another? We have lots of time. This is the only topic we're set to cover today because I know this is traditionally not easy, right? This is quite a bit more complicated than multiplication division, which are basically just big reducing problems where factoring is the only hurdle there. Here, it's a little bit more complicated, so I'm happy to do some more examples. You guys ready to move on to another one? So this one will be a little bit harder because I'm going to give you guys 3 fractions that we're going to add and subtract. Oh no! I promise you guys can handle it. It is scary though. But nothing really changes. What do we start by doing? Factor the denominators. Great. So how does x squared plus 6x plus 9 factor? Well, those would add to give us 0 and multiply to give us negative 9. Three and 2. You're getting closer. 3 and 3. Yeah. Multiplies to give us 9, adds to give us 6. Good. Okay, let's look at the next one. 3x minus 9. What can I do with that? Yeah, we can just take a 3 out. Everybody agree there? Okay. And the last one, x squared plus 3x. Don't forget to check for a greatest common factor before you start trying to factor anything. You should see that you can just take an x out. So far, so good? Oh, pooper scoopers. I meant for this to be a plus. Sorry about that, guys. That problem would become much more annoying if that had been a minus. I don't want it to be that annoying. Regular strength annoying is okay. All right. So, what prime factors does my least common denominator have to contain? Well, certainly we have an x plus 3, right? What else do we have? I have a 3 and also an x. Everybody okay with that? What's the most number of times the 3 occurs in any denominator? So when I say a 3, just once, right? We mean the coefficient. What's the most number of times the x occurs? Just once. When we're talking about the x, we're talking about the coefficient x, not the inside parentheses parts. And how many times does an x plus 3 occur? Twice. Because we're only looking at one fraction at a time when we're asking ourselves how many times does something occur, right? Looking at each fraction and the most number of times that occurs. So that's my least common denominator. Everybody happy there? Okay. So if I look at my first fraction, I have the I have 2x plus 3s. I'm missing the 3x though. So far, so good. If I move to the second fraction, I have the 3. I have 1x plus 3, but I don't have the second. And I'm missing an x also. That's embarrassing. And if I look at the last fraction, I don't have the 3. I have the x. And I have one of the 3, or x plus 3s. So I need the 3, and I need another x plus 3. Okay, so let's start multiplying some of these numerators out. Yes. Yes. So 3x times 3 is 9x. X plus 1 times x plus 3 is x squared plus 4x plus 3. But then I still have to multiply the x through. And then my last set, x minus 2 times x plus 3, is x squared plus x minus 6. And then I still have to multiply the 3 through. Oops. 18. So far, so good. Okay. So let's see, what do we have? We have 9x. And then this negative sign is going to distribute through. Now we'll combine our like terms. So I have a negative x cubed. I have negative 4x squared and positive 3x squared, just gives me negative x squared. Positive 9, negative 3, positive 3 gives me positive 9x. And then a minus 28. Yes, sir. Yes, sir. Everybody okay there? And you could try to, that's got 4 terms, so we could try factoring that by grouping, but it's not going to work. Should be relatively easy to see that when I take the first 2 and I pull a greatest common factor, I'm left with x minus or x plus 1. And I take the second 2, there is no greatest common factor, so the pieces don't match and you can't actually do this by grouping. So this is as good as we can do. And we're finished. What do you say? One more and we'll call it good for the day? Do you guys want me to write you down something, let you try it for a minute and then go over it together? How's that sound before we release you to work on homework? That's probably a good idea. Give you a chance to try something, get some immediate feedback. Right? We got lots of time. Let's do that. So I won't pick something as complicated as that last one. We'll just pick something that's kind of medium. So I don't know, we'll take 5 or 10 minutes here, let you guys work on this one, and then we'll go through it together, and we'll call it a day. Sound good? So in your notes or on some scrap paper or whatever, like, give it a try. Do as much as you can do, right? If you get stuck somewhere, that's okay. But give it a shot. It's really important that you try it now so that you get some feedback. So when you're doing it on your own later on, you at least feel like, okay, I've tried this once, like I've already gotten it, seen some of the places where I, do make a bad decision or do something in the wrong order, or I feel good about what I'm doing because I did the one in class right. Either way, like, you're going to get some important feedback as to like what to kind of keep an eye out for as far as mistakes you might make, or places where it's like, okay, I know that this is the place where I kind of struggle, so I need to do some more practice on this skill. Or maybe you're going to get good feedback and be like, yeah, I think I got this, you know? So now that you guys have gotten a little bit of a head start, I'm just going to kind of periodically add in some steps so that if you've made a mistake somewhere early on, you can at least come back and, you know, make some fixes now that I've given you a couple minutes of head start. Or if you're not sure how to get started, this will help kind of kick your butt in the right, moving in the right direction. We'll talk through this all in a row, but I figure as we're going, I can write in some of the work so that if you're stuck somewhere, or if you're like wanting to check what you've done so far, it gives you the opportunity to do that as we're kind of going. You guys ready to talk about this here? What do you think? Okay. So we started by factoring. So I got the first denominator factors x plus 2, x plus 2. The second denominator x minus 2x plus 2. So my least common multiple is x plus 2 to the second, because I have one denominator where that occurs twice. And then x minus 2 to the first, because the only place x minus 2 occurs is there, one place, one time. So the first denominator had 2x plus 2's, but it didn't have an x minus 2. The second denominator had 1x plus 2, but it didn't have the second x plus 2, and it already had the x minus 2. I FOILed out the numerators and then distributed the negative through to get here. I combined my like terms, so x squared and negative x squared, 0. Negative x and negative 5x is negative 6x. Negative 2 and negative 6 is negative 8. That gets me here. I then checked to see if I could reduce by factoring the numerator. The only thing I could do in the numerator was take out a greatest common factor of negative 2. But that still didn't get me any pieces that could reduce. So I stopped here as my final answer. Questions?